Welcome to MOVITRAC LTP-B Basic and Intermediate Training. This is session 11. We're fast coming to the end of our course. We have just a few more concepts to cover, but the one we're going to cover in this session and the next is pretty big, and that is the subject of field buses. Field buses are pretty sophisticated. They really move your MOVITRAC LTP-B up into the big leagues because by controlling the VFD with an external controller like a PLC, you can do a lot more things. So we're going to dive in and take a look at how you do this. First of all, several crucial big ideas. Let's define field bus if this is a new term to you. I've mentioned it a number of times already, but let's get formal about this. A field bus is an industrial communications network that links controllers and the devices they control. Controllers often include things like PLCs or similar devices. The devices they control are enormous, but in our case we're going to be focusing on VFDs. Most field buses today are based on the Ethernet communication standard, which is of course also used with computers. However, in the past there were many different field bus standards that were not Ethernet based. We'll be talking about all of those today. The MOVITRAC LTP-B is very versatile. It can connect to a field bus in 3 different ways. We're going to talk about all 3 of them. I'm going to remind you right now that these videos are chapterized, so you can skip around if necessary. I suggest if you're interested in only one specific way of communicating with a field bus, then you just jump directly to that. But be sure to watch the end of the video because there will be some things that apply to all 3 different ways tucked in at the end, plus a demonstration. Let's just review the field bus capabilities of the MOVITRAC LTP-B. I introduced these way back in the beginning of the class, but maybe you've forgotten about them, so a quick review is in order. The MOVITRAC LTP-B communications port, which is right here, supports 3 classic field bus standards: SBus, Modbus RTU, and CAN-open. What do I mean by a classic field bus standard? These are field bus standards that were introduced in the 1970s, 80s, and early 90s. They tend to be based on communication standards like RS-485 or CAN, which stands for Controller Area Network. When you compare them to modern Ethernet-based field bus standards, their communication speed is much slower, but that doesn't stop them from being useful. There are still a lot of classic field buses in use in many applications, mostly legacy, but some newer ones. The MOVITRAC LTP-B supports these 3. You may wonder, what is SBus? SBus is an SEW Eurodrive specific protocol that works on top of a CAN network. So CAN-open is another version of a CAN network. Both of these are similar. Modbus RTU, of course, is a well-known standard. It's been around for a very long time. All 3 of these are available on the built-in communications port. So if you want to communicate with one of these, you have pretty much all the hardware you need. You just need some cabling hardware. However, if you wish to use more modern field bus standards based on Ethernet, you can add a field bus card to the MOVITRAC LTP-B, or you can use an external gateway, which will give you the ability to communicate in that way. If you add a field bus card, and you can see one right here, it plugs into the slot right underneath the communications port, and these are the standards currently available: Ethernet IP, Modbus TCP, Profinet, EtherCAT, and BACnet. And then there's the external gateway option. An SEW external gateway has 2 pieces to it: the UOH11B, that's that orange enclosure, and then you put a field bus card in there. There are a number of standards available, and that turns it into a gateway. These are the standards available: Ethernet IP, Modbus TCP, Profinet, EtherCAT, Profibus, and DeviceNet. Those last 2 are also classic field bus standards. All the others are Ethernet-based. So you have 3 different ways of getting on a field bus with a MOVITRAC LTP-B. We're going to just cover these one by one, and we're going to start with classic field bus setup. This is what you do if you want to use the built-in communications capabilities of the MOVITRAC LTP-B and you want to get on a classic field bus. So to do this, you make all your connections right here. And this is a typical classic field bus setup. Notice you have multiple MOVITRAC LTP-Bs. Each one has a splitter cable assembly attached to its communications port. You link these up with RJ45 cables. These are just the type you would use for normal Ethernet networks, even though in this case it's not Ethernet. We do recommend, however, using shielded ones in an industrial environment. You simply chain the splitters together. The last VFD at one end must have a terminating resistor installed, and the PLC or other controller is the opposite end. It too needs some kind of termination as well. Cable sets A and B include splitters, cables, and terminators, so you need to purchase whatever is necessary to connect your VFDs. Notice the limit of how many VFDs can be on the network. If you're on Modbus RTU, the limit is 32. If you're on SBus or CANopen, the limit is 63. So you can set up a decent little Fieldbus with a classic Fieldbus standard. Also, this is again worth a reminder. Some of the IP55 and IP66 models of the MOVITRAC LTP-B have a built-in splitter inside. So in these, all you need are the cables and a terminator at the end. Pretty nice. And then one little extra here. If you replace the last splitter with cable set C instead of the regular splitter, you can connect a PC for engineering as well. Cable set C has two connections on it. One goes to the Fieldbus, the other goes to an SEW Eurodrive USB adapter like the USM21A. And cable set C contains an internal terminator, so it needs to be at the end of the network. But notice you don't have to plug a terminator into it, which is kind of nice. So this is probably the ideal setup because you can engineer the VFDs from your PC and everything can stay connected up to the Fieldbus. Pretty clever. All right, so once you get everything wired up, what do you do next? Well, you go to parameter 1-12 in the basic parameters and you need to select a Fieldbus control mode. You're very familiar with parameter 1-12. We've set it in a number of different ways for terminal control and keypad control. We're now going to change it to Fieldbus control mode, and that's these modes right here, 5 through 8. So you pick the one that corresponds to the Fieldbus standard that you're following, and that means that the VFD will listen to that particular Fieldbus and be controlled by it. You have to set a number of settings to get communications set up, and these are additional parameters. So you need to go to parameter 5-01 in the extended parameters. By the way, parameter group 5 contains a lot of Fieldbus related settings. And so what you need to do first of all is set the communications address of your VFD. Now this may ring a bell because we talked about this way back in the beginning when we started engineering our VFDs using the USB adapter and cable set C. And that's no coincidence because the engineering address and the Fieldbus address are actually one and the same. It defaults to 1, but of course on a Fieldbus you're going to need to set every VFD to its own address. So let's go through the rules of setting up addresses. First of all, each VFD must have a unique address. You do not want to have a duplicate address. That will cause all kinds of weird problems, so make sure every VFD is unique. Secondly, the addresses can be in any order. They do not have to be in ascending or descending order. They can be in any order you like. You do not have to have sequential addresses, in other words, 1, 2, 3, 4. You could just pick a random group of numbers from the available address choices. However, common sense really says it does make sense to have sequential addresses and have them in the order that the VFDs are connected up. That just makes your life a little easier. So I recommend you do that, but you don't have to. And then finally, here's a tip. It's better to set the address with the keypad than LT shell. The reason is as soon as you change the address in LT shell, that also changes the engineering address, and you'll lose connection with LT shell and your VFD as soon as you've changed it. You'll then have to scan back into the network to get reconnected. That's kind of a nuisance, so I recommend you just go into the keypad and set the address there directly. All right, once you've set the address, you need to do a few other things. You need to set what's called the baud rate. That is the rate at which the VFD and the controller communicate with each other, the number of bits per second that go flying over the Fieldbus. If you're using either SBus or CANopen, you set the baud rate in parameter 5-02 in the extended parameters. And here it is. These are the choices available. The default is 500 kilobaud, that's 500,000 bits per second. But you can pick these other values if you have some reason to. And incidentally, you should always remember that baud rate does affect the maximum cable length. The faster the baud rate, the shorter the maximum cable length is. The manual has a table that lists the baud rate and the cable length, so I recommend you consult that when you're setting up your Fieldbus and make sure everything is compliant. Now, if you're using Modbus RTU, you go to a different parameter in the extended parameters, parameter 5-03. And here it is right here. This is the Modbus RTU baud rate parameter. And these are your choices. Notice they are quite different from the ones used with SBus and CANopen. The default is 115.2 kilobits per second. And then you'll have to set one additional parameter, which you do not do with SBus and CANopen. You have to set the communications parameters. This is parameter 5-04, and these are the choices available. So set this to match your controller, and everything will be just fine. All right, so that's all you have to do to get a classic Fieldbus set up. Connect up the wires, set a few parameters, and you're pretty much good to go. So now we're going to transition to talking about using a Fieldbus gateway. This is a little more sophisticated, and it's definitely a different strategy for getting connected, but it allows you to use a lot of modern Fieldbus standards, so it's often desirable. Let's look at how this is done. So if you're using a Fieldbus gateway, you're going to connect it up to the communications port on your VFD. And what actually happens is something like this. The gateway has a local SBus Fieldbus. So that is what you're really doing when you're communicating with the VFDs. You're setting up an SBus. SBus, you notice, is set up just like a classic Fieldbus. You use splitter cables and a terminating resistor on the last one. These plug into the VFDs, but then instead of plugging into the PLC, your SBus plugs into a connection on your gateway. And then the gateway is connected up to the main Fieldbus, which is probably an Ethernet-based one, unless you're using a classic Fieldbus card in there. So you really have two Fieldbuses, your local Fieldbus, which is SBus, and your main Fieldbus, which is one of the common Fieldbus standards. By the way, you may notice that there is a limitation of 8 VFDs maximum when you do it this way. This is not a limitation of SBus, which can connect up to 63 VFDs. It's a limitation of the gateway. The gateway can only control 8 VFDs maximum. And in our next session, you'll see why. All right, so do be aware of that. Just a reminder, these are the protocols that are available through the gateway, depending on the card you have installed. So how do you get wired up? Well, of course, you wire up the VFDs in the usual way with the cables and splitters and terminating resistor, but then the gateway itself requires a connection to the first VFD in the chain. To wire this up, you need a cable with an RJ45 connector on one end and simply bare wires on the other end. What you can do is take an ordinary Ethernet jumper cable and cut off one end if you like, and that's what I've done here in my example. You have to connect up just 3 wires, and you connect up these 3 here. The color code on a standard Ethernet cable is orange, orange-white, and green-white. And you connect them up to connections 1, 2, and 3 on connector X26 of the gateway. You can see that identified right here. So simply cut off that end, strip them, insert them into the connector, and you're good to go. The gateway itself does require a 24-volt power supply. So you need to connect a power supply up to connections 6 and 7 on that same connector. You can see I've got one hooked up here. And that is all you have to do to wire up the gateway. So it's relatively simple. In order to configure your VFD to work with the gateway, you need to set a number of parameters. The first thing you do is go to parameter 1-12 in the basic parameters. This selects a Fieldbus control mode. We're very familiar with this parameter. We've used it many times before. You need to set it to a Fieldbus mode. So these are the choices right here that you can choose from, and when you're using a gateway, you must pick option 5, SBus MOVILink protocol. So be sure to pick that one. That's the one that will talk to the gateway. All right, so you set that as your control mode. Then you need to set some communication settings. You go to parameter 5-01 in the extended parameters, and you need to set the Fieldbus address. The address uniquely identifies each VFD on the Fieldbus. The communications address is set in parameter 5-01. This may seem familiar to you because this is also the engineering address. You may remember setting that back in one of the early sessions when we talked about getting connected to LT Shell. The engineering address and the communications address is the same. And let's go over the rules for setting these up. First of all, every VFD must have a unique address. You cannot have duplicates. If you do, you will have some weird problems, so be sure every VFD's number is unique. They can be in any order you like. They do not have to be 1, 2, 3, 4, 5. You can set them in any order. Nor do they have to be sequential. You don't have to just use ascending or descending numbers. You could just pick a random group of numbers and set them up. But let me urge you, do set them up in sequential order and have the VFDs set up in the order they're connected to the cable. It just makes your life a little simpler. That's just common sense. And a tip here, it is better to set the address with the keypad than with LT shell. And the reason is when you change the address, you change the engineering address at the same time. And when you do that, you will immediately lose connection between LT shell and the VFD. You'll have to then scan back into it, which is kind of a nuisance. So I think it's easier just to go into the VFD through the keypad when you set your address. Now, it's very important to understand this. The VFD's Fieldbus and engineering address applies only to the local S-bus and the engineering network. It has nothing to do with the Fieldbus addresses on the other side of the gateway. Those are totally independent, and they're probably completely different because the Fieldbus standard on the other side of the gateway is probably an Ethernet-based one, which will have a totally different scheme. So this is your setup. You might set your VFDs like this, and I have just demonstrated here that you do not have to use sequential addresses, nor must they be in order. I've set them to 3, 12, 7, and 19, although I think that would be a little crazy to do that in real life, but it would work. And then on your Fieldbus, which in this case is an Ethernet IP-based one, you would have an IP address. The gateway's address could be 192.168.10.4. That, by the way, is SEW Eurodrive's default address on many of its devices. And then your PLC would be something else within the same network, like 192.168.10.100. So notice everything is independent on each side of the gateway. Once you have your addresses set up, then you need to take care of some communications. So you need to set your baud rate. Baud rate is the number of bits per second that travel over the S-bus network between the gateway and the individual VFDs. You set this in parameter 5-02 in the extended parameters. These are the choices available, but for the gateway to work correctly, you need to pick option 2, 500 kilobaud. That's 500,000 bits per second traveling over the S-bus. So be sure to set it to this, otherwise you will not be able to communicate with the gateway. By the way, baud rate does affect the maximum cable length. The faster the baud rate, the shorter the cables have to be. Now we're talking the cables of the S-bus side of the gateway. The cable length on the other side depends on the standard you're using, which is usually Ethernet. If you have any questions about cable length, see the manual. It lists the baud rate and it lists the maximum cable lengths for that speed. Now, I'm going to mention this right here. Each Fieldbus card that you could put in your gateway has a procedure for setting up its address. You need to consult the appropriate manual for assistance. Some of the classic cards use dip switches. The Ethernet-based ones are set up using software. What I'm going to do is give you an example that applies to many of the Ethernet-based ones. This will apply to the Ethernet IP, Modbus TCP, and Profinet cards. All of these use a standard IP address. Each one of these cards has a dip switch that resets it to use SEW Eurodrive's standard default address, which is 192.168.10.4. The one we're interested in is the one that is DEF IP, stands for default IP. And so here's what you do. With the gateway powered off, you turn the default IP switch on. Then you turn the gateway on, you allow it to boot up. Give it plenty of time to do this. Then turn it off, turn the DEF IP switch off, and then turn the gateway back on. And when the gateway powers up, it will be on that default address, which is 192.168.10.4. Almost all of SEW Eurodrive's IP-based products default to this, so it's something you can count on most of the time. Now, time for an important note. What if you want to change the IP address to something else other than the SEW Eurodrive default? What do you do? Well, that depends on the particular card you're using. There may be several possible ways. Some can use external utilities to do this. A surefire way is to use MOVITrack's Motion Studio, which is SEW Eurodrive's engineering software for its B generation of products. We're not going to cover that in this class, so I'm going to just point you to the Fieldbus card's manual for more details because every Fieldbus card is slightly different. So if you want to change the IP address off the default, look in the manual and it will explain how to do this. All right, so once you have the gateway's address set up, you need to do something else. It needs to learn what's connected to it on the S-Bus side. So to function as a gateway, all Fieldbus cards must enter an automatic setup mode during which they scan the S-Bus for VFDs. So here's the procedure. Power down the gateway, connect and power up all the VFDs, turn the AS switch on the front of the Fieldbus card off, power up the gateway, then turn the AS switch on. You will notice that the H1 LED on the front of the gateway, which is right here, will flash. What it's doing during this time is scanning the S-Bus looking for VFDs, so it's kind of learning its local network. This takes a little time. Eventually, however, H1 will stop flashing, and that means the gateway has learned everything out there. Now, very important point, leave the AS switch on. If you turn the AS switch off, the gateway will no longer function as a gateway. So if your gateway for some reason appears to drop out, double check that switch. Maybe somebody turned it off by mistake. Now, if you add or remove VFDs from the S-Bus, you must perform this process again or the gateway won't work properly. So you need to learn the network every time you make some kind of a change. All right, well, that is how you configure a gateway to work with your MOVITRAC LTP-B. Now, a handy tip. I'm not going to demonstrate how to set up a Fieldbus gateway in this course, and the reason is I've actually done it already in a different course, so if you are interested in seeing how a Fieldbus gateway is set up, I'm going to point you somewhere else. To see a gateway setup demonstration, visit SEW Eurodrive's USA YouTube channel and watch session number 9 of the MOVITRAC LTE-B Plus training. I hope you remember that the MOVITRAC LTE-B Plus is similar to the MOVITRAC LTP-B. It is slightly less capable. It's a more entry-level product. In that particular session, I demonstrate how to set up a Fieldbus gateway, and it's almost identical to the way you set it up for the MOVITRAC LTP-B. So if you're interested in it, I recommend you visit that video, and I'm including a link in the description below. All right, well, that is everything we need to know about Fieldbus gateways. We're now going to move on to our third way of setting up a Fieldbus on the MOVITRAC LTP-B, and that is using a Fieldbus card installed directly in the VFD. So when you're using a Fieldbus card, it's relatively simple. You insert it in the expansion slot, which is right behind the communications port, and this will give you one of these Fieldbus standards. Notice all of these are Ethernet based. So they pretty much are wired up the same way using ordinary Ethernet cables and a network switch. However, there's a handy little feature on the Fieldbus card that may not have caught your attention, so I'm going to point it out. Every Fieldbus card has a built-in mini switch. So it's got 2-port mini switch, which means that you can simply chain your Fieldbus cards one to the other VFD to VFD using RJ45 cables. So you really don't need an external switch. You can wire it up exactly as it's shown here on the screen. Kind of handy. Now, how do you install the card? It's extremely simple. First of all, you need to remove the expansion slot cover, and you can just pop that off with your finger right here. And behind that is a slot. Then install the card by sliding it in until the connector mates, and then tighten the screws with a Torx 8 screwdriver, a T8. Kind of unusual, it's a little tiny screwdriver. That secures the card in place, and that's all you have to do. You're now ready to go. Of course, you do have to do some setup on the VFD, so everything works correctly, but it's relatively simple. First of all, you need to go to parameter 1-12 in the basic parameters and select a Fieldbus control mode. Of course, you're very familiar with this parameter. We've used it on many occasions to set things up, such as keypad control mode or terminal control mode. In this case, we're setting it up for Fieldbus mode, and when you're using a Fieldbus card, you need to pick option 7, which is Modbus/Fieldbus option module, and that, of course, is what you're talking about, the Fieldbus option module. So pick option 7, and you're good to go. You don't have to set anything else in the MOVITRAC LTP-B. Now, an important note, the procedure I'm going to talk about next applies to the Ethernet IP, Modbus TCP, Profinet, and BACnet cards. The only one it does not apply to is the EtherCAT Fieldbus module. I recommend if you're using EtherCAT, you consult the manual for assistance when setting that up. All right, now although you don't need to set any communication settings or other things in LT Shell, you do need to get the card itself configured, and this is done with an external utility. You need to set up the IP address. All the Ethernet-based cards except for EtherCAT use IP, so you need to set an IP address. Now, by default, the Fieldbus card is configured to get its IP address from a DHCP server. And in case you've forgotten it, DHCP stands for Domain Host Control Protocol. A DHCP server hands out IP addresses automatically to devices that request them. So if you're using a DHCP server, you don't have to do anything else. Just plug everything together, your server will hand the Fieldbus card an IP address, and everything will be all set. However, if you are not using a DHCP server, then you need to set the address. And this requires a number of additional steps, which I'm about to outline. If you wish to change to what's called a static IP address, in other words, you just hard code an address in there, you will need to download and install a utility. It's called the HMS IP config utility, and you download it from www.anybus.com. I'm including a link in the description below. They're the company that manufactures the electronics inside our Fieldbus card. So you need to install this utility on your computer. Then what you do is you connect your PC's Ethernet card to the Fieldbus card and then fire up the utility. What it will do, it will scan the Ethernet and it will look for any Fieldbus cards that it can detect on the network. In this case, I did it with my Fieldbus card when it was brand new, and it spotted it immediately. It found a Fieldbus card. It identifies it, and notice that it indicates that DHCP is turned on automatically. All right, so this is the default state of the card, and of course we're going to change this. So the next thing you need to do is click on the card to change its properties. So if you click on the card, it will change like this. Then you should uncheck this checkbox to disable using a DHCP server. Then you can set the IP address and the subnet mask. Notice I changed my card to use SEW Eurodrive's default IP address, which is 192.168.10.4. I set my subnet mask to 255.255.255.0. And I set my gateway to 192.168.10.1. You don't have to set a gateway if you're not using one, but I did in my case. And then once you've done that, finally you just click Apply. That will change the IP address in the Fieldbus card, and now it's good to go. And that is all you have to do to set up a Fieldbus card on a MOVITRAC LTP-B. Pretty simple and straightforward. Now we have some final setup. This applies to all Fieldbus types, whether you're using classic Fieldbus, using a gateway, or using a Fieldbus card, so everybody should watch this. First thing you need to do is set up how the VFD handles a communications fault. It is always possible, and indeed it's very common, to lose communications in a Fieldbus-based system. Of course, you need to know how to handle this so things will not go haywire on you. Parameter 5-05 and parameter 5-06, both in the extended parameters, determine how the VFD handles a communications failure during Fieldbus operations. We're going to look at parameter 5-06 first because it's the more logical one to cover first. This is the communications loss timeout value. It is a number which represents seconds, and it indicates to the VFD how long it should allow a communications loss to occur before it takes action. By default, it's set to 1 second. That means if you have a communications failure that happens just very briefly, less than a second, and then everything comes back, the VFD will ignore it and do nothing. But if the communications is lost for longer than a second, the VFD will take action. You can set this to a short value or a longer one. It just depends on your application and how aggressively you want the VFD to handle a communications fault problem. Now, once communications loss has occurred and you've exceeded this value, parameter 5-05 indicates what the VFD should do to respond to the loss of communications. These are the choices. The default is 2. So what the VFD will do by default is it will simply ramp to a stop using a deceleration ramp, and then it will halt. So this is kind of an orderly shutdown. It will not trip a fault. It will simply come to a halt. However, if you wish, you can pick something different. You could pick option 1, which will ramp to a stop and then trip a fault, in which case probably an operator will have to come back, press the stop button to clear the fault so things can resume. That is one option. Option 0 will trip a fault and coast to a stop. In other words, it won't use a ramp value. It will simply cut the power to the VFD's transistors. If you have a brake, it will bring it to a rapid stop. But if you don't have a brake, of course, it could coast for a while. And finally, option 3 runs the VFD at preset speed 8. It's kind of a fault speed. So these are the 4 choices that you can pick. You do need to pick one of these, and you do need to think about communications faults because they are relatively common in a Fieldbus operation. And then secondly, you need to set up what's called Fieldbus terminal control. Parameter 115 is very familiar to us by now. We've used it in terminal control on many occasions, and you may think, well, what does terminal control have to do with Fieldbus control? And the truth is, when you're in Fieldbus control mode, you still have a limited terminal control mode that is also available. So this is configuring what the digital I/O signals are going to do. So parameter 115, as you know, sets the digital inputs function. We often call this the control variant. And as you know, there are 26 variants plus the custom one. Now, when you're working in Fieldbus control mode, you need to pick a variant that includes something very specific. It must have selected speed ref as one of its speed options. And you can see one right here on number 1, which is the default variant. In some of our past activities, the speed reference was actually the potentiometer. But when you're operating in Fieldbus mode, the Fieldbus itself is the speed reference. So you need to pick a choice that includes it. 14 of these 26 do include it. And of course, remember, there's always the option of creating a custom terminal control variant. You set parameter 1-15 to 0 and make the Fieldbus one of the speed sources. You set this up, of course, in parameter group 9, and you already know how to do that. So just be aware of this. Remember, you do have terminal control kind of working in the background, and never forget that digital input 1 is the enable signal in most of these variants, and that still has to be enabled for the Fieldbus to be able to take control. All right, I think it's time for a demonstration. We're not going to do a hands-on in this activity because you may have a totally different Fieldbus card or method of connecting than I have. What I'm going to do is demonstrate using a Fieldbus card. I've got an Ethernet IP card, so I've put it into my VFD. I'm going to show you how to set up the VFD in LT Shell, and I'm also going to demonstrate how to set the IP address using the external utility. So let's jump into LT Shell and take care of that. All right, well, we're going to set up my VFD to use a Fieldbus card. I have an Ethernet IP card, which is a very common and popular one, so that's the one we're going to use. I've actually already installed it in the expansion slot in my VFD, but I haven't done any other configuration. As you can see, we're in LT Shell. We've got to set up a few things in the VFD first. We're right where we were after the last session, which, as you recall, was the scope lab. We don't have to do too many changes because setting up a Fieldbus card is relatively straightforward, but we do have to do a few things. So let's turn on real-time edit mode and we'll make a few changes. Some of these don't really have to do directly with the Fieldbus. For example, I want to change the acceleration ramp time to something quicker. I'll change that to 2 seconds, and I'll leave the deceleration time also at 2 seconds. All right, now one of the things I have to do for Fieldbus mode is I have to change it to be the primary control source. So I go to parameter 112 and I change it from terminal control to Fieldbus option module. That's option 7 here. That will tell it to use the Fieldbus card installed in the slot. I also do need to pick a terminal control variant in parameter 1-15 because, as I mentioned, the VFD does pay attention to its digital inputs. So I'm going to change this from 6, which is what it was for the scope lab, back to 1. That's our default, and that's perfectly fine. All right, now we're going to go to parameter group 5, which is where most of the Fieldbus parameters live. I don't have to set an address because we're using the Fieldbus card. I don't have to set baud rate or communications protocol like I would with SBus, CAN Open, or Modbus RTU. But I do need to set up communications loss timeout in action. Now, first of all, I'll go to parameter 5-06. That's the timeout, how long the VFD will wait after losing communications before taking action. It's set to 1 second. I'm just going to leave it there. You can see we can set it anywhere between 0 and 5 seconds. Set it to 0 if you want an immediate handling of a communications loss. 1 second is fine here though. And as far as communications loss action, by default, it is set to ramp to stop without a trip. Remember, we do have other choices that we could use, but I think I'm going to leave it on the default. That sounds fine to me. All right, we do need to do one additional change. It has to do with something we were doing back in the last session. We had fault monitoring turned on. Now we've changed to a variant that doesn't include it, but there's another parameter that if we don't change it, it's going to just keep the fault monitoring active. So we need to change to parameter group 2. We need to go to parameter 2-33, analog input 2 format, and change it from motor thermistor to 0 to 10 volts. That will shut off fault monitoring. We also need to do one other thing. We need to change the fast deceleration ramp in parameter 2-25 to 1 second. We're going to use this in our next session, so we might as well set it now. And that's all we have to do. So now we can turn off real-time editing and move on. And that is all we have to do in LT Shell. We're now all set to go. However, we do have to configure the Fieldbus card itself, but that is done using a separate program. Okay, I'm ready to configure my Fieldbus card. I've connected a cable between my PC's Ethernet port and the Ethernet port on the Fieldbus card. I then fired up HMS-IP-config, which is a third-party utility produced by the company that makes the electronics of the Fieldbus card. And as you can see, it has discovered my Fieldbus card. It's a Compact-Com Ethernet IP. All it does, it scans the network to see what it recognizes out there. And you can see that the card is currently configured to use a DHCP server. You see it says DHCP enabled. Now I want to switch to a static IP address, a fixed IP address. I want to use the SEW Eurodrive default, which is 192.168.10.4. So what I'm going to do is just click on the line of the Fieldbus card right here, and it allows me to configure it. Now notice we've got a checkbox here for DHCP. I'm going to uncheck it, and that will turn off DHCP, and now I can enter an IP address. So I put in 192.168.10.4, which is the SEW Eurodrive default IP address, and I need to set an appropriate subnet mask. So I'm going to set this to 255.255.255.0. And finally, for the gateway, I don't have to set this, but I'll set it anyway. I'm going to choose 192.168.10.1. And that's all I have to do. I don't have to set anything else. I'm not going to set up a domain name server or anything. So then I just click Apply. It applies the settings to the card, and you can see now it shows DHCP is disabled, and you can see my new IP address there. That is all I have to do to configure my Fieldbus card. Now, the final thing you should always do after configuring a Fieldbus card is just be sure that you can communicate with it at a very basic level. This is called pinging the card, and it's just a smart thing to do because it ensures that at least you've got basic communications working. So what I've done here is I've fired up a command prompt in Windows, and if you don't know how to do that, it's really easy. Just click the magnifying glass on your taskbar and type in the word command, and it will give you the option command prompt. And if you click that, you'll get a window here sort of like this where you can type commands directly to the operating system. Now what I'm going to do is just ping my Fieldbus card. I'm still plugged in with my cable between my laptop and my Fieldbus card. So what I'm going to do is type ping 192.168.10.4, hit enter, and you can see it is getting a reply back from the card. That means I have basic IP communications up and running. If this fails and you don't ping successfully, don't go any further. Go back and take a look at your Fieldbus card. Go into HMS IP-config, check things out. You're not going to get anywhere if you can't at least ping the card. But in our case, we did successfully do that, so we're now set up and ready to go. And that is the end of session 11. That was a long session, but Fieldbuses are pretty complicated. In our next session, we're going to take a look at the software side of things. How you send processed data words over the Fieldbus to control the VFD. If you're a PLC programmer, I'm sure you'll find a lot of this interesting and actually necessary if you're going to write a PLC program to control a MOVITRAC LTP-B. So, on that exciting note, See you next time.